I would like to introduce our panelists. First we have Dr. Neno Duplan. He's the founder and CEO of Locus Technologies and really has devoted his career to combining an understanding of environmental science with a vision of how to gather, organize, visualize, and analyze, well, there's a lot of I's there, environmental data in order to help companies better manage EHS and sustainability. Locus Technology Software, we're actually the world's first commercial software as a service product for environmental information management going back to 1999, and the company continues to evolve over time. Dr. Duplan has a PhD in civil engineering from the University of Zagreb, Croatia, and a master's in civil engineering from Carnegie Mellon, yay Pittsburgh, and a BS in civil engineering from the University of Split, Croatia. And then a fun fact is that actually Neno could have played the lead role in the movie Aquaman, or Aquaman, depending on what country you're from, because he has completed the Alcatraz to San Francisco swim 15 times. An annual event, otherwise known as Shark Fest.
So we as a company, as Peter has said, started way back in 1999 and implemented the first software as a service when it wasn't even used as acronym platform to organize multiple applications on the web that all talk among themselves. And no single customer is subscribed to all of them, but you can make a combination of any of them. And the advantage of the approach that we have chosen is it's a multi-tenant, it's multiple applications that can be connected. So if you input information on in one application for health and safety or waste, it carries over to the next application if customer chooses to expand. And today I will focus primarily on IoT because that is a very promising technology. We not only offer software as a service as a platform, but we also offer the platform to our customers to build applications for themselves. So many consultants come with applications that we never heard about, and they can use our technology that is very configurable, drag and drop, and build application within hours, build a form that we don't even have in our system. And infrastructure is, we have switched to Amazon Web Services a few years ago, so it's a highly secure and available around the world at any location, because there are a number of countries that don't allow you to use infrastructure if the application is not hosted on their territory. Obviously, security is very important in all of that, and Amazon takes care of that for us. And my friend Catherine from Symantec will talk more about that tomorrow. There are two major platforms and a mobile that interacts with both of them that we offer. One is very vertical, primarily dealing with analytics and analytical chemistry, organizing and the workflow process from cradle to grave, and the platform that I already covered. I want to talk about Internet of Things. This is a very important technology because we are now switching to the world of connected devices. And the way the technology has progressed is a kind of cornerstone of what's happening around us as more and more devices get connected, from your refrigerator to Nest thermostat, and the list goes on and on. However, there is a little issue here, because if you look at how many devices are getting connected, one of the research analysts predicted that 26 billion devices will be connected to internet by year 2022, and internet as it stands today simply cannot handle that traffic. And most of those devices are connected all the time and streaming the data. There is a single point of failure in this model, and that's the cloud itself. And there are practically only 4 companies that now control 90% of the cloud traffic, and you know who they are. So can we trust just 4 companies to handle the world information? I just took a picture of this article from last Monday from Wall Street Journal. Forget gigabyte, we are now even in a territory that we don't know how to call it. And 26 billion devices connected to internet means about 5 devices for every citizen of this planet. And obviously, that's a problem. And the problem is going to get solved with something called blockchain. You may have heard the name, but not familiar with technology. It originated with cryptocurrencies, but has nothing to do with Bitcoin. It's a technology that is so powerful that's going to decentralize how the information flows on internet. So for example, if Peter sends me a text message, that text message travels to the cloud, 10,000 miles somewhere, who knows where, to his provider, then to my provider, back to me, and it would be only one word. So that's a huge traffic to manage. And yet Peter and I are only 5 feet apart. And in the new model based on the blockchain, that information will travel between Peter and me in 5 feet and reduce that traffic. And that's really the core message that you need to understand and pay attention to this technology, particularly when it relates to monitoring, reporting, and security. There are a number of layers of technologies that need to exist before this come into the place. And this is the model from Carnegie Mellon University, and we've been working with them. And many of the elements of these layers are already in place and in the process of testing. And you will see a lot of new information coming. There is an article here that I have a link that will be provided that you can read more about it to save time. I will skip to the concluding and just we are in Silicon Valley. We believe we know what we are talking about and are prepared for the big future. Thank you.
Can you talk about an environmental monitoring, environmental management use cases related to IoT, industrial Internet of Things, and then maybe from there layer on how blockchain could extend that solution or add more value?
Sure. So, environmental monitoring falls in the category today of streaming data more and more. Air emissions have been around for a long time, but now the continuous monitoring devices are connected directly to internet and feed the data into some kind of system database out there. And as I mentioned during the presentation, the limiting factor is rapidly becoming the throughput of the bandwidth and the cloud to process a vast amount of information, interpret it on arrival, and send the signal back when you have exceedance. And that is where technology is going to drastically change in years to come, because blockchain is going to change that. And if you think how that process works today, company collects the data, puts it in a database, and then generates a report through some reporting structure that submits to some regulatory agency that has yet another incompatible system on receiving end. With the blockchain technology, every partner in this network between a company, consultant, and ultimately the government who receives information will be the member of the blockchain, and each piece of information is going to reside in a blockchain technology with significantly improved security over the system. And there will be no double input between company who owns the emissions and a governmental agency who receives it. They will simply have an access to the same information. And then to follow from that emissions trading, it becomes much more simpler, because you have only one system of record, not only within the company, but between the company and the government and all the players. And security is extremely important. That's part of the reason why blockchain first landed in a cryptocurrencies world, because security was of concern there. I don't know how much you follow. The Bitcoin is really not a good example here because it had such a wild ride, but the technology has made it in the mainstream, and there are companies like Ripple that already handle 25% of transactions of foreign exchange and currency transactions. So before, what you had, if you're sending wire from here to Europe or Mexico or wherever, it would touch a couple of banks, intermediaries, to make that transaction possible. It would take 24 to 48 hours, and you are exposed to the risk of currency exchange. And in the process, everyone takes a little cut, not big, but significant if you do large volumes. Ripple technology today makes the transaction in a couple of seconds, so you practically eliminate the currency fluctuations, and you eliminate the middleman, another bank in England or somewhere where that happens. Same thing applies to emissions. You can have a real-time reporting without really writing any reports and submitting to regulatory agency. Another example would be chain of custody that we all are familiar with. You take a sample, you have a piece of paper, you triplicate, quadruplicate, that follows that sample from point of collection to lab analysis. That all could be eliminated by chain of custody, creating a block of the sample on the web and sharing information with the receiving entity, customer, consultants, and whoever else has a right to see it. And that's going to make a big difference in years to come.